Welcome to Nomis Academy. In this video, we'll be dealing with Venn diagram involving three sets. Venn diagram. So this will be our Venn diagram part 2. Diagram. So remember, I said John Venn invented Venn diagram to give a pictorial picture or diagrammatic explanation of sets. So now we'll be dealing with Venn diagram involving three sets. So how do we interpret a few of those set notation using Venn diagram? So let's take this as set A, and this is our set B, and this is set C. So remember that these set A, set B, set C are subsets of the universal set. So we have the universal set here. That means, and the idea of universal set in Venn diagram is that if we have set A, set B, set C, and we have their elements, and within them we may have intersection or union. So if we have, we could still have a set that are not that the elements are not in A, the elements are not in B, and the elements are not in C. What do we call it? Yes, A, B, C complement. Now, so we have A complement, B complement, C complement. So we don't have it in A, we don't have it in B, we don't have it in C. Are you getting it now? So this part is a set, it contains the elements of a set that the elements cannot be found in A, B, or C. So that's why we should have a universal set which encompasses the entirety of the set that we could have. Now, let us interpret A intersect B intersect C. So if we have A intersect B intersect C, so where do we have there? Where do we have to shade? This is A, this is B, this is C, and we have where they have commonality. So A intersect B is here. So you can see that at this point C is not included. So this is just A intersects B. So this cannot be A intersects B intersects C. And here, if you check here, this is A intersects C. A intersects C. This particular part is A intersects C. So it does not include. Here is A intersects C. This particular part is A intersects C. Why this include the three sets A, B, and C, and this is where they all intersect. This is where A, B, and C all intersect. So if I'm to tell A intersect B intersect C using Venn diagram, I will just shade this portion. So this particular part is A intersect B intersect C. So that is where the three sets intersect, that is, they have the common elements. So let's take on the second diagram. Let's have this to be our set A, set B, and set C. And what we want to do here is A intersect B intersect C complement, intersect C complement. That is, C should not be involved. A and B. This and I said now is not union, I mean intersection. So where do we have common elements of A and B and C is not involved? So A and B, A and B. So this particular area will be shaded, not extending to any other part. This is where we have A intersect B intersect C complements. So this is where we have it. So So we have it here, A intersect B. So we can say that C entirely is not included in this diagram. So remember that this is our universal set. So let's move on. So let's take on this, the next one. Let's take this to be set A, set B, and set C. So what do I want to show here? I want to show A intersect B complement intersect C. So in this time, the complement is on set B. That means set B should not be included. So if set B should not be included totally, and I need to tell about the intersection of A and C, that means this is where A and C will intersect. This is set C and this is set A. This is the only place they intersect to exclude set B. So I will only shade this part, the diagram. So this is A intersect B complement intersect C. So let's take another one. Let's take A intersect B complement intersect C complement. So in this case, we have complement on 2. We have complement on two of the sets. So don't forget, let's take this as our set A, let's take this as our set B, let's take this as our set C, so that this remains our universal set. So if this is our universal set, so A intersect B complement, meaning that B entirely should not be involved, and then C complement, C entirely should not be involved. Then we'll be left with just the side of A. We'll be left with just the side of A. So we only shade this particular part. So this is A intersect B complement intersect C complement. So let's take the fifth example. So let's take our set A to be here, set B to be here, and set C to be here. And this is our universal set. So what do we want to tell here? We want to tell A complement intersect B intersect C. So here we have A complement. That means A is totally excluded. So we have B intersect C. So where does B and C intersect? Only this part, B and C only. So B and only. So it will be that only this part. So this is where they intersect. And that is A complements intersect B intersect C. So let's take the sixth example. Let's take this as our A, B, and C. So what do we want to show here? Let's see. A complement intersect B intersect C complement. So you can see what we are just doing is just to find out where to shade on this. So you see A complement meaning that A is totally excluded, and C complement means C is totally excluded. So it has to be B. So the only part of B that we can like this. So just like when we have A intersect B complement intersect C complement, so those ones that are complements will not be part of what will be shaded to show. So what we are left with A, and in this case what we are left with is just B. So this is A complement intersect B complement. This is A intersect B, A complement intersect B intersect C complement. And that is the final for our lessons. I hope you understood everything we did in this video. Watch out for it carefully. Try A union B union C. Try A union B complement union C. Try A union B intersect C. So and try to see if you will get the correct Venn diagram. Bye bye. See you in the next video.